All right, so first thing we're going to look at today is section 1.1 in the book. It's more of a review of algebra, as I said. It doesn't get into any trigonometry at all. But really quick, for like 2-3 minutes before we even look at that, I just want to look at the word trigonometry and kind of break that word down a little bit into like maybe a prefix and a suffix and see if we can kind of figure out what that word means. Okay. Does anyone recognize when you look at that word, like any part of that word that you've seen before in another word? Could be a math word, could be a non-math word. Yeah, is it Emma?
I don't know, like geometry, metry.
So metry, yep. So metry is definitely a suffix, something at the end of the word that you see in all kinds of subjects, like trigonometry, geometry. I guess that's it. So metry is at least in a couple subjects. And does anybody know what metry means? Well, if you look at it, M-E-T-R. There's another word that begins M-E-T-R. Yep, metric. Metric has to do with a unit of measurement, how you measure things. So metry has to do with measurement. So in trigonometry, we are measuring something. Does anybody recognize anything else in the first part of the word? Yeah. Try. Yeah, what's that mean? 3. So 3 something measurement. Well, the word gone, that means something too. That means sided. Right? We see that all the time in like hexagon, octagon, pentagon, words like that. We don't normally say trigon. We normally say triangle. Right? But every shape has a name for it that ends in gon. So triangle, you could also call it a trigon. Does anybody know the name of a 4-sided shape that ends in gon? That'd be 8. So oct would be, that'd be 8. That's all right, you gave it a shot. That would be, but it's like that, but it's the prefix that means 4. And it's quad means 4, but we use that with quadrilateral, which does mean 4-sided shape, but there's another prefix that means 4 besides quad. Yep?
Like tetragon?
Tetragon, yes. So if you've ever played Tetris, tetra means 4. That's why in Tetris, all the shapes have 4 blocks. Okay? If it was a different prefix, it would be a different number of blocks. Tetra means 4. So tetragon is a 4-sided shape. So what we're basically doing is measuring triangles. That's what trigonometry is. Measuring triangles. So really, really quick basic example. There's the ground. You've got a building over there. You're standing here, and you know that you're standing 100 feet away from the building. How do you know that? I don't know. You measured it. And let's say that you're looking up at the top of the building. And you're looking up, and you know the angle you're looking at. How would you know the angle? Very easy. There's a device you can use to measure angles of elevation. You see it sometimes with surveyors. You've ever driven and you see like tripods set up, and then there's like a guy looking through it, and then there's like another tripod further down the road. Anyone ever see those guys set up? The tripod? They're measuring things. They could be measuring distances, they could be measuring elevation, maybe they're measuring the grade, because when you build like a house, you gotta have a certain grade to the yard so the water drains away from the house. Who knows what they're measuring? But there's ways to measure all these kinds of angles, okay, using what's called a transit. So let's say you measure that angle, and it's 40 degrees. There's enough information there to find the height of what you're looking at. You know how far away you are. You know the angle to the top of the building. I'm not going to do it, but you could. And here's your triangle. Here's your triangle right there. In that case, specifically, that's a right triangle. So we'll spend a week talking about right triangle trick, and we could do some applications like that. Another example that is a non-right triangle. Let's say you've got this. This is going to be water on this side. It's going to be land. Out here, you get a boat. And there's 2 Coast Guard stations on the land. Like that. And let's say the boat is having some kind of problem. All right? Their radio works, but their GPS is out. They can't figure out where they're at. Right? And it's cloudy, it's nighttime, so they can't see any landmarks on land, can't see any stars. So they got their radio, and that's it. They're trying to call for help. Like, we don't know where we're at. We need a direction to get back to, back to land. So let's say that on the top of this boat, they have a light. Okay? So they can at least be seen by other people. Most boats have lights on. So if each one of these Coast Guard stations can see that light, maybe it rotates, so they can see it from different directions. But as long as each Coast Guard station can see where the light is on that boat, the 2 Coast Guard stations can work together and tell the boat exactly where they are. That's called triangulation. You're figuring out where a third person or third thing is using 2 other people to do it. So the idea is, if this Coast Guard station was working by itself and it didn't have anyone else to help them, all they could say is, we can see the light that way. They would know if it's 20 miles that way, 30 miles, 40 miles. They could see a light, but they don't know how far away it is. I could just say the light's coming from that direction. Well, the other Coast Guard station can do the same thing. They don't know how far away the light is, but they can say, we see the light coming from that direction. Now, the 2 Coast Guard stations can each see the same light. They can triangulate exactly where the boat is. You do have to know how far apart the Coast Guard stations are, but that's usually pretty easy because the Coast Guard stations are probably marked on a map. So they could just look at a map and say, okay, we're 100 miles apart. And then here is your triangle. You can do exactly the same thing if there's a fire in like a forest. So if you've ever hiked at Mount Wachusett, there's a tower on the top. That tower is used so they can spot different things in the forest. If there was a fire, they're up higher so they can see it. Well, pretend like that boat is a fire. If 2 ranger stations can see where the fire is, they can pinpoint and tell a helicopter or whatever that's maybe dropping water, there's where the fire is. Okay? If you only have 1 station that could see the fire, all they could say is the fire's that way. We can't tell you if it's 50 miles that way or 60 or 70. All we can see is smoke way over there, but we don't know exactly where. Well, a helicopter would have to know exactly where to be able to get to it, right? And figure out if it's got enough fuel to get there and things like that. So they can triangulate where something is. Do the same thing with cell phone towers. If your phone is on, a cell phone tower can ping where you're at, and usually police can ask a cell phone company to do something like that. And depending on where you are, if they send a ping to your phone, you're going to be in range of certain towers. Your phone will respond with a ping. That ping is going to go to a cell phone tower. The more towers that you're in range of, the more accurately they can figure out where you are. Right? The downside of that is somebody that's not supposed to be able to do something like that can also try to figure out where you are. And that's not something you want to happen. You're not supposed to be able to do that, but there are people that can figure out how to ping your phone. And it doesn't even matter like if your GPS is on or anything like that. As long as you're in range of a cell phone tower, you can get pinged and your location can be determined for good or bad. Works the same way. GPS satellites also the same kind of thing. GPS is a little more complicated to triangulate because now you're talking 3D too. Are you on the ground at this location or are you 20,000 feet up in the air? Big difference. Something like this is more of a 2-dimensional problem. It's all triangulation. So as we go through stuff, I'll try to talk a little bit about how you could use it. Trig is something that's very easy to apply practically to different fields. Now, if you're not, if you're going to be in culinary, you may never be trying to triangulate the position of a boat in the middle of the ocean. Maybe that's not your job. So I can't relate every single thing to every single field. But I can usually relate to at least one or two fields, an application that we do. And not like some kind of fake, kind of application. Like somebody said, well, you're in Cosmo, you might use trigonometry if you calculate the angle between where you put like hairspray and makeup, and then if you keep that angle under 30 degrees, it's really? That's not real. So I mean, it's probably not, that's just real. So I mean, I'm talking about I can usually find something that's a real application. All right, so that's trigonometry, all about triangles. All right, so what we're going to look at in this section, very, very short section, is two formulas. Distance formula, midpoint formula. The reason I'm doing the distance formula is because it involves a square root. And square roots are something that we're going to use all the time in trig. So the idea of the distance formula is that you've got 2 points, and you're just trying to figure out how far apart the 2 points are on an XY axis. Not even really connecting this with a word problem here. But you just got 2 points. You're just trying to find out how far apart they are. Let me just make that a little smaller. So there's my 2 points, A and B. I've got them as green dots. A has an x and a y value. B would have an x and a y value. So when we do an actual problem, it would be more like, I'll just show you an example, more like that. Find the distance between, and then they're going to give you all numbers. Okay? But for now, we don't have any numbers. Just find the distance between them. So I said trigonometry usually involves something with a triangle. It's going to be our first thing. Right off the bat, we're going to make a triangle. I want to find the distance between A and B. Easiest way to do it is to make a triangle. Just like that. It's always easier on a graph to measure horizontal and vertical distances. Diagonal distances are hard to measure. Right? The reason horizontal and vertical is easy is because you have grid lines. All you have to do is count. Diagonals, you can't count grid lines because it's on an angle. So the idea here is we're not going to be able to find the distance between A and B directly. But what we are going to be able to find is this and this. And if you know those two things that I just drew in bold, you can find the diagonal using a formula from geometry. So let's look at the bottom. I got that green dot, and I got that green dot. So step one is I'm going to try to figure out how long the bottom is. If you have a number line, think of it like 0 to 5. Let's say I put a point here and here. Now I could count. Let's say I didn't have a picture. I just told you I've got a point at 1, I've got a point at 5. Tell me how far apart 1 and 5 are. How do you do that with arithmetic? To figure out how far apart 1 is from the number 5. Yep. Subtraction. Yeah, anytime you want to figure out how far apart two things are, all you have to do is subtract. Okay? So to find the length of this bottom side, all we have to do is subtract two numbers. When we're trying to find the distance between those two green dots on the bottom, do you think we would be looking at subtracting x values or subtracting y values to find how far apart those two green dots are? Well, Kyle, what do you think? Think you'd be subtracting x values or subtracting y values? How come? Not sure. Well, you know what? Let's call this point over here C. We can write the coordinate for point C. We have enough information there to write it. Not numbers, but we have letters that we could put. We know the x value for point C, and we know the y value. The x value for point C is the same as the x value from what other point? Because they line up. Yeah?
It would be B.
It's the same as B. B and C line up vertically. If they line up vertically, that means they've each gone over the same amount. Now, what about the y value for C? Look at what other point it lines up with and look horizontally. Point C is the same height as what other point?
Point A.
Point A. So, if you look at points A and C, my question was to find out how far apart they are. You wouldn't want to look at the y values because they're the same. And if you subtract two things that are the same, you get 0. And the distance between A and C is not 0. So what we have to do here is subtract the x values. Let's say this x value was at 2, and this x value was at 10. That means the distance between them is 10 minus 2. They're 8 units apart. So that's the length of the bottom side. Now, based on that, anyone think they can tell me how I would get the height? Still going to have to subtract two things, but what do you think I'm going to focus on this time? Yeah, go ahead, Ariel. The y values, right? y1 maybe is at 0. y2 is maybe up at 5. Subtract them, and that'll tell you how long that side is. So this is y2 minus y1, and that's the distance from here to here. So the two important things are that and that. Now, does anybody know what the formula is if you know two sides of a triangle to get the third side? Yeah?
Would it be A squared plus B squared equals C squared?
Yeah, what's that?
I can't remember the name.
But that is the formula. Anyone remember what it is? It's the Pythagorean theorem, right? Pretend like this is A and that's B. So A squared plus B squared equals, and you could call that other side C squared. So now I'm going to write down the formula that you guys just said, but I'm going to write it exactly like that. I have x2 minus x1, that's the length of the bottom, so that's one side squared, plus y2 minus y1, that's the other side, that's the height, and you square it. And to do the Pythagorean theorem, you have to add them up and take the square root. So what I basically did is the Pythagorean theorem like this. Yes, it is a squared plus b squared equals c squared, but if you want to know what c is, just take the square root of both sides. So square the base, square the height, add them up and take the square root. Base, height, add them up, take the square root. So the distance formula is really just the Pythagorean theorem. That's what you're doing when you find the distance between 2 points. Okay, so let's try the distance between those 2 points. 4, 5, and 3, 2. First thing I would do is just label them. Let's call this one x1 and y1. And we'll call the next one x2, y2. Now, I could have switched, I could have had the 3 be x1 and the 2 be y1. I just wrote the labels in the order that I had. Okay, next thing I usually do, set up the square root and set up your formula. If you write all that first, then you won't forget part of it later, because there's a lot of stuff there. There's addition, subtraction, square roots, and squaring. Okay. And some people ask, well, can you just simplify that because it's the square root and a square? And you can't because of this plus sign. Okay. There's no shortcut to that formula. That's as short as you're going to get it. And now you just fill in those 4 spots, those 4 numbers. So, Michael, the first one is x2. What am I filling in for x2?
3.
Yep, 3. Samantha, the next one is x1. What am I putting in for that?
4.
Yep. And Sheridan, next one is y2. 2. And the last one is y1. 5. Okay. So let's simplify it and see what we get. 3 minus 4 gives me -1. And Nick, when I square -1, what do I get?
1.
1. Plus. How about Anna, right? Okay. 2 minus 5 is how much?
-3.
And what about when you square -3? 9. Done. That's the distance between those 2 points. If they wanted a decimal, you could just go on your calculator and type it in. But if they don't ask for a decimal, you can leave it just like that. Any question on that one? Okay. Now, square root of 10, you're done. There's nothing else to do. Okay. Let's look at this one. I'm not going to go through the whole problem again because I just went through how to do a distance, but I will tell you that the distance comes out to square root of 20. If you end up doing it, you have 4 minus 2, which is 2. And when you square that, you get 4. 10 minus 6 gives you 4. And when you square that, you get 16. That's where the 20 comes from. Okay? But the problem here is square root of 20 is not simplified. Okay? And that's what I explained right here. So if you were to do that whole problem out, you would get square root of 20. We have to simplify square roots as much as we can. Some square roots you can simplify, some you can't. Square root of 10? No. Square root of 11? No. 12? Yes, you can simplify square root of 12. Okay? So I'm going to show you how you can simplify it if it's one you can simplify. And there's lots of ways to do this. This is just the way that I show. If you have a way that you use already and it works, just do what you're used to doing. So the idea is to factor the number that you're trying to simplify. So it's something times something. One of the numbers has to be a perfect square. Okay? Remember, perfect squares are numbers like 4, 9, 16, 25, 36. They're all numbers you can take square roots of nicely. Anyone think they can tell me how I can write 20 as something times something?
4.
It has to be a number in this list. Yes, 4 times 5. That's the first step. Just try to write your number as something times something. And one of them has to be a number in this list. Now, step 2 is to break it into 2 problems. All you do to break it into 2 problems is that. Just separate it, square root 4, square root 5. And now you can see why we did that. The square root of 4 is what number? 2. So the answer to this problem is 2 square roots of 5. And that's as simple as you can get because now you can't simplify the square root of 5 anymore. 5 is a prime number. Some people like to make a tree. If you do a tree, that works fine too. We just did example 3. I'll do one more of those. Let's say you get a whole distance problem and you ended up with the answer square root 48. That's not simplified because 48 can be written as something times something, and one of the numbers is in that list. Anybody think how I can break up the number 48? Yep.
4 and 12.
Yep, you can. You can do 4. You can do 12. And Colby, right?
Yeah.
What's the square root of 4? We just did that. 2. Now, the way Colby did it isn't wrong. It's fine. But you have to do it again. Because now you can simplify 12. If you have to do it twice, that's okay. But that means there's a way you could have done it in one step. And I'll show you that next. So we'll finish doing it this way, and then I'll show you how you could have done it in one step. So 2, how can you break up 12? 4 and 3. And the square root of 4 we just did. 2 times 2 gives me 4 square roots of 3. Perfectly fine to get at the answer that way. That works. Now, does anybody see a different way you could break up 48? And if you do it this way, you're done in one step. Emma?
16.
Yep. Not in your times table, so that's why you might not think of that one. 16 times 3, and the square root of 16, 4. So you're done in one step. I don't care how many steps you take to get to the final answer. Either way is fine. Right? But there is always a way to do it in one step. Sometimes bigger numbers are harder to do in one step because you don't see the biggest number right away. So do it in multi-steps. Break it down. Okay. Any question on that? Okay, so last thing is midpoint formula. Midpoint formula, it's just in the same section as distance. It has nothing to do with square roots. Usually these two formulas are taught together. I'm not as concerned about this one. I am going to ask you a question on the test about it. But I'm more concerned that you know how to work with square roots. So the midpoint formula is a little different than the distance formula. You're not finding how far apart two things are. You're finding where the middle of two things is. And from statistics, you might kind of recognize what's going on here. When you add two things up and divide by 2, that gives you the what of the two things? The average, or the mean. Okay? So the midpoint formula, all you're really doing is averaging the x's and finding the middle value, and then averaging the y's. That's how I remember it. It's just an average and another average. Specifically, an average of two things. Okay, so we'll do one midpoint formula, and then that'll be it. Okay. So this one says find the midpoint of those 2 points: 3, 4, and 7, 13. Okay, I didn't label what's x1 and y1 this time. I'll just kind of ask people as we go. Okay, so Sadie, what could x1 be in this case? Sure. She picked 3. Dennis, how about x2?
7.
Yep. So we're going to add those up. Divide by 2. We'll simplify in a second. Jace, what's y1?
4.
4. And then y2, 13. Okay, so the midpoint. Ian, what's 3 plus 7?
10.
And then divide by 2.
5.
We get 5. And this one is 4 plus 13, which is 17 over 2. You can leave it as 17 over 2. It's fine. Or you could put it as a decimal, which would be how much? 8.5. If the directions on the problem didn't say which way to leave it, I would accept either answer. And that's the midpoint formula. Okay. Questions on that? Okay. So the homework for tonight is all that. Don't forget to copy these problems in black. Page 7, that's in your book. 15 to 21 odd, those are some distance. 39 to 43 odd, those are some midpoint. And then the ones in black are some square roots just to practice simplifying. Okay, square root of 40, square root of 28, square root of 108, and square root of 1440. Okay, so we don't have as much time left today because we spent like 40 minutes going through the syllabus. But you got about 5-6 minutes. So if you want to talk quietly, that's fine. Just please stay in your seats for me until we know. Oh, also, do not forget to get the sheet signed. That'll be the other part of your homework.